come to question 3. The front and back clocks in a spaceship traveling at relativistic speeds are both reading 12 p.m. according to passengers in the spaceship. However, according to observers on Earth, the back and front clocks might respectively read what? Okay, so this refers to the concept of simultaneity. One of the effects of relativity, of those two postulates that I covered, is that events and clocks that are simultaneously reading the same time on one reference frame are not necessarily going to be simultaneous in another reference frame. Even events, like if two events were to happen in a certain reference frame exactly at the same time according to that reference frame, then what's going to happen is that according to another reference frame moving relative to that reference frame, those two events will not take place at the same time. So this is known as simultaneity. Simultaneity. Okay, so in this case, what's going to happen? Well, you have a spaceship moving at close to the speed of light, so v, and then you have a person here, and you have a person here. And you have two clocks. The back clock is the clock that is on this side of the motion, so we can call this back, and then this is the front clock. Okay, so let's say they are simultaneous. Well, what would it mean to say they are simultaneous? They are simultaneously reading the same time. Well, what's going to happen to envision this? You have to think of a thought experiment. In order to have them simultaneous, imagine as if this person in the middle stands right at the middle of those two clocks, right? And sends a beam of light simultaneously, sends a beam of light and a beam of light. So that's the only way that you can envision how is the person in the rocket going to make them simultaneous. Well, there has to be a certain source that's sends a beam of light here, sends a beam of light here, and triggers both of the clocks, right? So that they start at the same time. Exactly at the same time from the reference frame of the rocket, right? So this beam of light gets there, this beam of light gets there. At the same time, they are simultaneous. Now, according to the person on Earth's reference frame, is the beam of light gonna get here earlier or later than this, or are they gonna get there at the same time? Well, since the back clock is moving forward to meet the beam of light, right? So the back clock is here, the beam of light is coming, the clock is moving forward. So the distance that it has to cover, the beam of light has to cover to get to the back clock is going to be less than the distance that the beam of light has to cover to get to the front clock. So which clock will start first based on an Earth observer? The back clock will start first, right? So the back clock will be ahead. So whatever time it's reading, so let's say the first time when you got started, you started at 9 a.m. It was early in the morning. The person here set both of them at 9 a.m. Well, what's going to happen? This one is going to reach here first according to this. This one is going to read 9 a.m. Right? Then a certain amount of time is going to pass depending on the velocity of the rocket. And then that one will read 9 a.m., right? They're going to start at 9. So this one will be 9 a.m. By that time, this one has been running, right? So it's been running. It's not going to stand at 9 a.m. Maybe it's going to be 9:02 or 9:03 or 9:04 or 9:05 or whatever, right? So by the time that this one is 12 p.m., this one will have been 12:02 p.m., right? So the back clock, this is the back, and this is the front. So the back clock is always ahead of the front clock. So which of the following scenarios is likely to happen? It can't be A, 12 p.m., 12 p.m., because that would go against the issue of simultaneity. Can it be this one? Now notice here what it says. The back clock and the front clock respectively read what? So it has to be the back and the front. Can the back be reading 12 p.m., the front be 12:05? No, it can't be, right? Because the back would be ahead of the front. So it has to be this scenario. The back can be 12 p.m., right? While this one is a little bit behind 11:55. You could have said 12:05 and 12, right? You could have said 12:05 and 12 here. So that would have been also a right choice. But it can't be 12 and 12:05, right? So it's got to be, this one has to be ahead. So the answer is that this one is 12 in our case. This one is 11:55. So whichever scenario has the back clock ahead of the front is the correct scenario. The same thing would happen if you didn't have clocks. Maybe a certain event took place. Maybe over here you turned on the TV. And then over here you turned on the TV. Let's say there's two TVs. And let's say the person in the spaceship turned both TVs on at the same time. You have a remote control, boom, okay? So they simultaneously turned both TVs on. Which TV is this person gonna think turned on first? So it's gonna be the back TV that turned on first, right? So any event or clocks or anything like that, that are simultaneous in one reference frame will not be simultaneous in another, okay? So this is a very important relativistic concept. Thank you very much.